Okay, so we're going to start 12.2 day 2, and this is where we get practical applications of linear inequalities. I'm going to do a couple example problems, and then you guys can work out the rest of the packet and also start your homework. Our situation is this. So suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound, and cornmeal costs $2.50 per pound. You want to spend less than $25 on the flour and cornmeal, but you need at least 6 pounds altogether. So our goal is to write and graph a system of linear inequalities. All right, so let's talk about what we know. We're going to buy flour and cornmeal, and that's important. We know that we're buying two different things, flour and the cornmeal. Okay? And we want to make the flour tortillas and the corn tortillas. Our flour costs $1.50 per pound, and cornmeal costs $2.50 per pound. Now we're limited on what we can spend. We want to spend less than $25 on the flour and the cornmeal combined. But we need to buy at least 6 pounds altogether. Now I've gone through, and as I read that, I highlighted some important things. I know the price per pound of the flour, the price per pound of the cornmeal, and I know how much I'm going to spend. When I think about how much I'm going to spend, the key word here is less than $25. So I could spend $24, $23. Technically, I could spend $0. So my sign here is going to be less than, like that. However, I need to buy at least 6 pounds altogether. At least means 6 is my minimum, which means I need to buy more than 6 pounds, like 7, 8, 9. So when I say at least, I'm going to also have a greater than sign. At least tells me a minimum, which means every value has to be greater. So now I can write two inequalities. I know how much I can spend is $25 or less than $25. To know that, then, I have to think about how did I spend the $25? Well, I spent it on flour and cornmeal. I know that it cost me $1.50 per pound of flour, but I don't know how much flour I've actually bought. Okay. I also know that I'm spending $2.50 per pound on cornmeal. But again, I don't know how many pounds of cornmeal I bought. Finally, I know that I need to buy at least 6 pounds of cornmeal together. Well, or 6 pounds of flour and cornmeal. So the amount of cornmeal, X, plus the amount of cornmeal, Y, has to be at least, that means greater than, 6 pounds. When I've done this, I have two linear inequalities. So I have to write two possible solutions, which means I need to convert both of these to slope-intercept form. So what I'm going to have is 1.5x plus 2.5y is greater than, or is less than 25. I'm going to subtract 1.5x from both sides, and that's going to leave me with 2.5y minus is equal to minus 1.5x plus 25. If I divide both by 2.5, both sides by 2.5, I'm going to find my y value, and oops, I let that equal sign get in there, not good. I find that y is less than negative 1.5 over 2.5. I can divide 0.5 into both of those, and I can reduce that negative 1.5 over 2.5. I can reduce that to 3/5. That's going to be negative 3/5 x plus 10. And I can go ahead and graph this. Now, on my graph, my x represents my flour. So let's do that color-coded. My y value represents my cornmeal. right, so now I'm ready to graph this. And I'm going to do that. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're just going to count by ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice I stopped counting at 10. I know my y-intercepts are 0, 10 and 0, 6, and both my slopes are negative. So I'm never going to be above 0, 10. So I graph this first function here, 0, 10. I'm going to go down 3 and to the right 5, down 3 and to the right 5, down 3 and to the right 5, and I know this is a dot, and I'm supposed to shade underneath, and that's what I'll do. I don't quite get my x-intercept, but it's, as we're going to see, it's not that important at this point. For the other equation, my y-intercept is 0, 6. I'm going to go down 1 and over 1, or to the right 1, and continue to do that. Again, a dotted line. And I'm going to shade above, which means my dual shaded region is what I'm doing in red right here. That means any combination of flour and cornmeal within that red area would be a solution. So for example, I could buy 7 pounds of corn and 4 pounds of cornmeal. So 7 pounds of flour and 4 pounds of cornmeal. In addition, I could buy 3 pounds of flour and 6 pounds of cornmeal. And that's how I would do this first problem. There are a number of different solutions within that red area. If you'll notice, 7 pounds of flour, 4 pounds of cornmeal, that would be a total of 11 pounds, which is greater than 6. 3 pounds of flour, 6 pounds of cornmeal would be greater than 6 pounds. But here's the interesting thing. If I take my 7 pounds of flour and 4 pounds of cornmeal, if I add that up, 7 times $1.50 is going to be $8.50. 4 pounds of the cornmeal at $2.50 will cost me $10. So $10 and $8.50 would be $18.50. That's less than $25. 3 pounds of flour will cost me $4.50. 6 pounds of the cornmeal will cost me $14. So $14 and $4.50 is only $18.50 as well. Both of these are less than $25 spent and more than 6 pounds altogether. Our final example, you'd like to see how many baseball and soccer games you can attend this spring. Travel time for baseball games is 2 hours and soccer games 1 hour. You would like to spend no more than 15 hours traveling to the games. In total, you'd like to attend at least 8 games. So, the travel time for baseball games is 2 hours. The travel time for soccer games is 1 hour. Those are going to be rate of changes. They're going to be slopes because it's 2 hours per baseball game, 1 hour per soccer game. We don't want to travel for no more than 15 hours of traveling to all the games. However, we want to attend at least 8 games. So our key words here are going to be at least and no more than. No more than is a max, which means everything has to be less than 15 or equal to 15. I can attend 14 games, 13 games. I can travel. It's not the very phrase that. I'd like to spend no more than 15 hours traveling. I can spend 15 hours traveling. That's not more than 15. I could spend 13 hours, 12 hours, 10 hours, 0 hours. So this is going to be less than or equal to 15. At least 8 games, at least is always a minimum, which means I need to at least attend 8 games. Maybe I could attend 9 games, 10 games, whatever. That's less than or equal to. 8 games is at least 8 games. Okay? So let's write our inequalities then. Well, it takes me 2 hours to travel to a baseball game. And for every baseball game I travel, it's going to be 2x hours of travel. X representing the number of baseball games, 2 the hours to travel to a baseball game. I'm going to add that to 1y, because it takes me 1 hour to travel to 1 soccer game. So for y number of soccer games, it's going to take me 1y times. And the total amount of time travel can be no more than 15. So that's less than or equal to 15. In our other equation, we're going to add the total amount of soccer games and baseball games, and that has to be at least 8. So that gives me x plus y is greater than, sorry, I made a mistake here. That should be greater than or equal to 8 games. At least is a minimum, has to be greater. At this point, these are easy to get into slope-intercept form. 2x plus y is less than or equal to 15. I subtract 2x from both sides. And y is less than or equal to negative 2x plus 15. On the other side here, I have x plus y is greater than or equal to 8. Subtract x from both sides, and I get y is greater than or equal to negative x plus 8. My x value here is the hours the baseball game travel. So we'll call it baseball travel. Or actually, it's the number of baseball games, right? The number of games determines the amount of time I spend traveling for baseball games. And the other one is going to be our soccer games. And I should probably have that in green to color code. As I graph this, the first equation, I'm going to go up 15, 0, so I'm going to count like my 3's here, but I'm going to start at 0, 15 here. I'm going to go down 2 and to the right 1, and I'm going to continue to do that. And somewhere between, it looks like I'm going to go somewhere between 7 and 8 baseball games there for my x-intercept. This is a solid line, so solutions on the line can be part of it, and I'm shading beneath. And go ahead and graph the other graph. My y-intercept is 0, 8. My slope is down 1 to the right 1. And I'm going to shade above. I have an intersection point that we're going to talk about, and our dual shaded region I've done in black here. Now I'm ready to answer questions. You'll have to go to the next video to see the answers to these questions.